Okay, in our previous segment we talked about atoms. So now we want to talk about how these atoms hook together to make minerals. So we need to have a definition of what a mineral is. So these are the different parts of that definition, and you should know them all for the exam. So that they are naturally occurring, and so for example, we can make a substance, a synthetic diamond, that looks exactly like a real mineral diamond, but it's not considered to be a mineral. So it has to be naturally occurring. You find it in nature for it to be considered to be a mineral. Okay, it needs to be formed by a geological process. And pearls, for example, were not considered to be a mineral, but now they are. So a pearl is now it's called a biogenic mineral. They are going to be solid. So ice could be considered to be a mineral, but if ice melts and it turns into water, then it's no longer considered to be a mineral. They have a ordered atomic structure. They have a definite chemical composition. So like for example, all calcite is calcium carbonate. So that's its chemical formula. Halite is NaCl. So that's salt. So it has a definite chemical composition that goes with it. Also, they have to be inorganic. So sugar crystals, they kind of look like a mineral, but they are organically made, and so they are not considered to be a mineral. Okay, what kinds of shapes do minerals make? I would say the only one that you need to know is the cubic. So that's going to be halite. So halite makes cubes. So I would not worry about the rest of those different kinds of shapes. Okay, then here's just some examples of atomic structure. So again, take a look at halite and you see that it's making a cube. Okay, how do we make a mineral? So they come from they can come from the solidification of a melt. So for example, in our previous segments we talked about how at a mid-ocean ridge that material comes up in a liquid form and then it hardens. So minerals form from the solidification of a melt, and notice that you can destroy a mineral if you heat it. So that if you heat up a mineral, it turns back into a melt. You can also form a mineral from the precipitation from water. So this is how calcite forms. So carbon dioxide mixes with ocean water, and then it turns into calcium carbonate, and then it precipitates to the bottom of the ocean floor. But under certain circumstances, a mineral can dissolve if you put it into water. So an example of this would be, again, halite. Take halite, put it into water, and it dissolves. A mineral can form from a precipitation from a gas. So an example of this would be sulfur. Sulfur is a gas that comes out of volcanoes, and you might notice that the rocks around the vent of the volcano are yellow, and so that comes from the precipitation of sulfur directly onto those rocks. Minerals can be formed biologically, so that certain shelled organisms can pull calcium carbonate out of the water and then use that to make their shells with. You can also form a mineral chemically, so that sometimes the calcium carbonate will just naturally chemically form. Okay, so let's okay, and then also under the destruction, you notice that for all of those they can be destroyed the same way. But then there's also solid state diffusion, and so this is where you start with a mineral, but then the individual atoms migrate inside of it, and then that alters the structure, and therefore it alters what the mineral is. All right, let's take a break. When we come back, we'll talk about how do you identify minerals.